So today I'm going to be talking about factoring. Factoring is something that we learned in chapter 4. Usually we factor quadratic expressions. Quadratic expressions are equations or expressions with an x squared in them and no higher. Can't be x to the third. That would be what we call cubic. We'll get into that later. But for now, quadratic expressions, if you see an x squared, you know you have one. So first step is to find the greatest common factor, the GCF as we abbreviate it. I'll show you guys an example. 10x squared plus 6x. We need to factor out the greatest common factor of these two. So we need to ask ourselves, what goes into 10x squared that also goes into 6x? So what we're going to be doing here is the opposite of the distributive property. So looking at this, I know that 2 goes into 10. I know that 2 also goes into 6. Not only that, I see that there's an x that's along with the x or the 10x squared, and I see that there's also an x with the 6x. So I can take out a 2x from each of these. So I'm going to be doing the opposite of the distributive property. So 10x squared divided by 2x leaves me with 5x plus 6x divided by 2x is just 3. In this case, we have factored out the greatest common factor of 2x. So this is a very, very basic problem. I'm going to get into a more complex problem that you're going to be using very frequently. But it holds true that for every factoring problem, you should always check for a GCF first. Before you do anything else, always check if there's a GCF, greatest common factor, first. GCF equals greatest common factor. Now, this equation or this expression that I have up here is in what we call standard form. Well, you'll see ax squared plus bx plus c, where these letters will be replaced with numbers. You'll have to assign these. And I'll show you how to do that in just a second. But the general process that we're going to use is the diamond method and the box method together. So when we use our diamond, we'll have a times c on the top, we'll have b on the bottom, then we'll find the factors of a and c, a times c, the factors of them that add up to b, but also multiply to equal a times c. And it'll make more sense once we start doing it. I'm going to show you the general formula before we begin. Then once we're done with that, we're going to use our area model. The only thing that we're going to take from this diamond are the numbers that we put here. In this bottom left corner, we're going to have ax squared. In this top right corner, we're going to have c. Then what we're going to do is we're going to plug in these two values that we get. And then from here, we ask ourselves, what does this column have in common with itself? And that will go here. What does this row have in common with itself? That'll go here, and so on. It'll make a lot more sense once we start doing an example. So let's get right into that. So I'm going to do an example from your week 11 worksheet, number 6. So week 11 worksheet, number 6. And this is x squared minus 4x minus 5. So in this case, I can assign my a, b, and c values. So in this case, a equals 1, b equals negative 4, and c equals negative 5. So the reason why a equals 1 is because when there's no number, they call that a coefficient, in front of the x squared, we just assume that it's 1. So whenever you see just x squared, know that your a is equal to 1. Now we're going to follow this formula for the diamond. So we use our diamond method. It's going to be a times c, so x squared times negative 5, that'll be negative 5x squared. And then b goes in the bottom, so that'll be negative 4x. Now what I do is I find the factors of negative 5. So the only factors of -5, two numbers that can be multiplied by each other, are 1 and 5. But obviously one of them has to be negative, right? Because 1 times 5 doesn't equal -5. The question is which one? Now when we add these two together, we have a result of a negative number. That tells me that the larger number must be negative, because when we add these together, it must result in a negative number. We have to multiply them together to equal a negative number. So the two terms I'm going to put over here are 1x and -5x. I got those from here. Now I'm going to circle these because this is all that I'm taking from the diamond. The diamond is used to fill in the box method, nothing else. So now, going back up to our formula, we're going to have ax squared in the bottom left, so that will be just x squared, right? And then the top right, we're going to have c, which is -5. And then we can fill these in to here. So we can put 1x here and -5x here. You could do it vice versa. You could do it the other way as well. You'll get the same exact answer. Now you ask yourself, what does this column have in common with itself? So what goes into x squared that also goes into x? And the answer is x. What goes into x squared that also goes into -5x this way? That one's also x. Now you can continue to do that for the rest of these, but what I prefer to do is I prefer to ask myself the question, x times what right here equals -5x? So x times what equals -5x? That would be -5. X times -5 equals -5x. And then do the same thing on the other side. So x times what right here equals 1x. That'd be 1. Is that a positive one or a negative one? It's a positive one, so I'm going to add a plus right there between them. Now I have my two terms. We're going to take these and we're going to rewrite it as factors. So the way that looks is like this. X plus 1 times x minus 5. That is the answer to this question. When we're asked to factor this equation, or this expression, we come up with this. So I'm going to show you guys a little bit more of a complicated one. X squared plus 5x plus 7. And this is going to serve as a lesson of some sort. So first things first, as always, we should check for a greatest common factor. Does anything go into these, all three of these numbers that can be pulled out? The answer is no. The only number that goes into all three of these is 1, so we disregard that. We don't do anything with that. So A equals 1, B equals 5, and C equals 7. Now, I continue on with my diamond. So A times C, x squared times 7, be 7x squared. And then B goes on the bottom, 5x. What are the factors of 7? What two numbers can you multiply together to equal 7? 1 and 7, 2 doesn't work, 3 doesn't work, 4 doesn't work. This is the only factor. Sorry, these are only whole factors of 7. So is 1 plus 7 equal to 5? I hope you said no. In which case, we would learn that this expression is not factorable. These exist. You can have expressions that are not factorable, and we'll talk about that in chapter 5 videos, about what those look like. Because there still are solutions for these equations, or these expressions, but we just can't factor them. They don't turn out nicely. So I'll show you guys one more example of factoring. Let's see. This is also going to be from your week 11. And let's do number 8, see if it works. So week 11, number 8. So we have 5v squared plus 18v minus 8. These have v's in them, that's okay. We're going to treat them the same way that we treat the x's. It's no big deal. So in this case, a equals 5, b equals 18, and c equals negative 8. We're going to factor these. So first ask yourself, is there a greatest common factor? Does any number go into all three of these? Answer is no. So we're going to begin with the diamond method as per usual. So on the top we have a times c, so that'll be 5 times negative 8, negative 40v squared. And on the bottom we have 18v. What are some of the factors of negative 40? Well, I can think of 1 and 40, 2 and 20, 3 doesn't work, 4 and 10, 5 and 8, 6 doesn't work, 7 doesn't work. So let's see. Have we done all of them? 1 and 40, 2 and 20. Yeah, this is all of them. So at this point, we notice that we have a negative number that's we multiply to equal a negative number, which tells me one of these must be negative. Now, when we add those together, we get a positive number. So what that tells me is that one of these is going to be negative, one of them is going to be positive. But when we add them together, it'll equal a positive number. So that tells me that the negative number must be the smaller one. So I'm going to make all of my smaller numbers negative. Now, I'm going to add these together and see if they equal 18 down here. So negative 1 plus 40 is 39, doesn't work. Negative 2 plus 20 is 18, that works. So we're going to have negative 2v and 20v. I circle those because those are the only things that I'm taking into my box. Now remember, the box always has ax squared, which is going to be 5v squared, and then c up top right. And then we fill in from our diamond negative 2v and 20v. Like I said, you could switch these around, doesn't matter. But now we ask ourselves, what do they have in common? So this column right here, what do 5v squared and negative 2v have in common? That would just be v. V goes into both of them, but nothing else. Then what about this row right here? Let's see, 5v squared and 20v. Well, I know they each have a v, and then also 5 goes into 5, and 5 goes into 20. So 5v goes into both of those. Now I ask myself, 5v times what right here equals 20v? Answer would be positive 4. V times what right here equals negative 2v? That would be negative 2. So these are my factors. We end up with 5v minus 2 times v plus 4. That's my answer. These ones are a little bit trickier when they have a coefficient in front, but the process is still the same. Don't be afraid. That's about all there is for the basics of factoring. I'm going to make one more video about special cases where I talk about differences of squares, perfect squares, and such. So stay tuned for that. Otherwise, these are the basics. So best of luck.